Hello and welcome to helpyourmath.com. In this video, we're going to talk about the real zeros of polynomial functions. First, we're going to go over a few definitions, and then we're going to look at some examples of applying those definitions. So first, a little bit about the graphs of polynomial functions. And in case you need a little refresher, a polynomial function, what that means is that all of the variables have positive integer exponents. So they have 1, 2, 3, 4. They don't have the square root of 2. They don't have negative. They don't have other decimals. Okay, so a little bit about those. A polynomial function of degree n can have at most n real zeros. So for example, if it's degree 7, then that function can have at most 7 real zeros. Depending on whether it's even or odd, it could have as few as 0 or 1, but we can talk about that later. And one other piece of information, the polynomial function can also have at most n-1 turning points in its graph. And a turning point is just another name for a relative extremum. Remember, there are two types of relative extrema. There's a relative minimum and there's a relative maximum. So if we have a polynomial of degree 7, that means that it could have at most 6 turning points. Okay, now we're going to talk about 4 equivalent statements. These 4 things tell us the same piece of information. So it can be written in any of these 4 ways and they all mean the same thing. Before we get to those 4 statements, though, we have a little bit of background definition. If f is a polynomial function and a is a real number, these are our equivalent statements. Number 1, x equals a is a 0 of the function f. X equals a is a solution of the polynomial function f of x. X minus a is a factor of the polynomial f of x. A comma 0 is an x-intercept of the graph of f. So those 4 things, we have a 0, which is the same as a solution, which is the same as an x-intercept, which if we put it back into factored form, we would say that putting that behind a x minus that thing would be a factor of the polynomial. Notice also the different jargon for defining that function. We can call it function f, we can call it function f of x, we can call it just polynomial f of x, or we can just go back to f. So those kind of a little bit of an offshoot there, but those also mean the same thing. Okay, one more definition before we look at examples. The definition of repeated zeros. So a factor of a polynomial x minus a to the k, where k is greater than 1, that means that we have a repeated 0, x equals a, of multiplicity k. So if it was x minus a to the 7th, we would say that x minus a has a multiplicity of 7. And that multiplicity tells us something that occurs at that point. If k is odd, which 7 was, that means that the graph would have crossed the x-axis at x equals a. So what that means is that if this is a here, the graph would go through a. So it would go from negative to positive, or maybe it goes from positive back down to negative. So it crosses through a. If k is even, the graph touches the x-axis, or I like to say it bounces at x equals a, but it does not cross the x-axis. So it's going to turn back around at that point. So if a is right here, and the graph starts up here, it would be coming down, 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 it touches and goes back up. Or if it started out below the x-axis, it goes up, 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 it touches a and turns back around. So there's a turning point at a if a is even. If a is even. Now, it's important to know the difference and be able to kind of recognize this pretty quickly. So I came up with just a nice acronym to help me remember, and I think it helped my students too. I just say EBOC. So even, bounce, right? That's one option. If it's even, it bounces. If it's odd, it crosses. So even, bounce, odd, cross, EBOC. Hopefully that will help you too. In our first example, we're given f of x equals 2x to the 6th minus 8x to the 5th. We have 4 things that we want to do. 1, identify how many real zeros f can have. 2, how many turning points can the graph have. 3, what are those real zeros? And 4, will the graph bounce or cross at each 0? To answer parts A and B, we need to know the degree of the function. So what's the degree? Remember how we find that? It's the largest exponent of any term. So this is a degree 6 polynomial because the largest exponent I see is 6. How many real zeros can f have? It can have 6 zeros because it can have the same number of zeros as the degree. How many turning points can the graph have? It can have 1 fewer than its degree, so it would be 6 minus 1. It can have at most 5. What are the real zeros of the graph? Okay, so to find that means what we want to do is set f of x equal to 0. So we would say 0 equals 2x to the 6th minus 8x to the 5th. The first thing we want to do is decide whether this equation has, or the right-hand side, if there's any greatest common factor. Are there any common factors? Yes, there is. So we're going to factor out the greatest common factor. 2 and 8 are both divisible by 2. X to the 6th and x to the 5th are both divisible by x to the 5th. And that would leave behind x minus 4. Now we set, this should be a 0, not a 6. Now we set each factor equal to 0. So we would say 2x to the 5th is equal to 0. You can use the zero product property here to tell us that the 0 will be 0. But if you don't feel comfortable and you need to go through the math, that's fine too. We would have x to the 5th is equal to 0. Take the 5th root of both sides. And voila, we get 0. The other factor here is x minus 4. So we set that factor equal to 0. And that would have a 0 at 4. Okay, lastly, does the graph bounce or cross at each 0? For this, I like to organize my information in a table. So I'm going to have 3 columns. The first is the 0. The second is its multiplicity. And the third is EBOC, even, bounce, odd, cross. So my first 0 is 0 itself. Going back to where I factored it here, so this is what we're going to look at from here on. What is the multiplicity of that? It was 5, right? The exponent of the x here, that factor, was 5. And even bounce or odd cross, 5 is odd, therefore it crosses at 0. So we use the multiplicity to tell us what it does at the 0. Okay, the other 0 was 4. Now it just says x minus 4 and then there's no exponent behind it. So what's the identity here? What is the exponent behind it? That would be an exponent of 1. So even though 1 is not a repeated 0, we can still say that 4 has a multiplicity of 1. And what do we care about the 1? We care that it is odd, indicating to us that the graph will cross 4. The graph will cross at that intercept 4. It's going to cross, it's not going to bounce. So what does that mean about the graph? Well, we have an intercept here. 1, 2, 3, 4. We have an intercept here. It basically means the graph goes through, and then at some point there must be a minimum between 0 and 4, and it comes back through 4. So notice that the graph comes down, it crosses at 0, comes back up, it crosses at 4. Okay, in our final example, we have the same 4 questions, but this time the function is f of x equals x to the 5th minus 3x to the 4th minus 4x to the 3rd plus 12x squared. So first and foremost, what's the degree of this polynomial? This is a degree 5 polynomial. So that means it can have at most 5 real zeros, and it can have at most 5 minus 1 turning points or 4 turning points. Next, we want to answer part C. What are the real zeros of the graph? So to do that, we set f of x equal to 0. That would be 0 equals x to the 5th minus 3x to the 4th minus 4x to the 3rd plus 12x squared. The first thing we want to ask ourselves anytime we're factoring is there a GCF among the among the terms? And the answer is yes. All 4 terms have x squared. So we're going to factor out the x squared and rewrite this as 0 equals x squared. We're going to divide x squared into each one, so that's going to leave us with x cubed minus 3x squared minus 4x plus 12. Now with this polynomial with 4 terms, we want to see if we can factor by grouping. So I'm going to group together the first 2 terms, and I'm going to group together the second 2 terms, but I do have to be very careful with that minus sign. I'm actually going to rewrite this as plus negative, because that minus sign could lead us astray. We can't have that in front of a grouping symbol, because then it should get distributed, and it's a whole big mess. So I'm going to attach it back to that 4x. Okay, so now what we're going to do is inside the parentheses, we're going to pull out GCFs that we see. X cubed minus 3x squared has a GCF of x squared, leaving behind an x minus 3. In the second grouping, because that first term is negative and I would like for it to be positive, I'm going to factor out a negative, and then 4 and 12 are both divisible by 4. So what I'm really doing here is I'm dividing both terms by negative 4, because I need that first term positive so that it hopefully matches this one. Which it does, because that would be x minus 3 when we divide negative 4 into 12. Now inside the brackets, I do have a GCF, or a common factor I should say. I have x squared, I have that common factor, x minus 3, and then what do I have left? I have x squared from the first term and minus 4 from the second term. Whew, now what do? Set each factor equal to 0. And actually, before I do that, what I notice here is that this can be further factored. That is a difference of squares. So before I set each factor equal to 0, I'm going to go ahead and factor that because I need to have this in factored form to help me with the next part, with part D. So this will factor into root minus root times root plus root. Okay, now I'm ready to set each factor equal to 0. So x squared equals 0. That means that x must be 0. You can take the square root of both sides. You're going to find out that x has to be 0. If I set this one equal to 0, that would be x minus 3 equals 0. Therefore, x equals 3. If I set this factor equal to 0, that would be x minus 2 equals 0. We would get x equals 2. Here, x plus 2 is equal to 0. We would have x equals negative 2. So how many zeros did we end up with? We ended up with 4. Is that allowable? Yeah, because we could have had at most 5, and we have 4. Whew. Okay, now part D. So part D, I'm just going to take my factored form and just put it up here, because that'll kind of help me focus. So I'm just going to say f of x equals x squared times x minus 3 times x minus 2 times x plus 2. I also probably want to answer, well, I guess I could just do this and say, look, here's part C. Yay! Okay. Let's go back. And now part D. So part D, we want to know, is it going to bounce or cross at each 0? So this is where I like to set up my table. I'm going to have the 0, its multiplicity, and then EBOC, even bounce, odd cross. I want to put my zeros in order. So the smallest 0 I see is negative 2, followed by 0, then 2, and lastly 3. The multiplicity of negative 2, so negative 2 is this one here. What's the multiplicity? What's the exponent? I don't see 1, which indicates to us it's an exponent of 1. 1, what do we need to know about 1? We need to know that it's odd. Therefore, the graph will cross the x-axis at negative 2. The next 0 is 0 itself. That was this factor here. That factor has a multiplicity of 2. What do we need to know about 2? That it is even. Because it's even, that indicates that the graph will bounce at that 0 of 0. Next, we have the 0 of 2. That was this factor here. What's the exponent of this factor here? That was an exponent of 1. Because 1 is odd, the graph will cross the x-axis at 2. And lastly, we have 3. 3 has a multiplicity also of 1. That indicates to us that the graph will cross the x-axis at 3. So what does this mean? What does this look like? Basically, very roughly, if I sketch this, we would have a 0 at negative 2, a 0 at 0, a 0 at 2, and a 0 at 3. Stop. Okay, it keeps wanting to jump to the next slide. And this is the last slide for this video, so don't get ahead of yourself here, PowerPoint. All right, so what does this tell us? This tells us it's crossing through at negative 2. At some point, there must be a maximum. It comes back down, and what happens at 0? It bounces. So it's going to turn, let's do this nice and smooth. It turns back around. Then what's going to happen in between 0 and 2, there must be another maximum. So it has to go up and come back down by 2 and cross through the graph at 2. Then in between 2 and 3, there must be a minimum. So it goes down, at some point it comes back up, and then it crosses again at 3. So looking at this very rough graph, this is by no means perfect, I should see the graph crossing the x-axis exactly 4 times. Once, or touching or crossing, interacting with the x-axis 4 times. It crosses once, twice, 3 times, and it bounces once, which is what we had here in letter D. This has been examples of what we can do with the zeros of polynomial functions. Thank you for stopping by.